is a variable that can store multiple values of the same type in adjacent memory locations. So you declare it like that. You say, oh, I want room for 5 ints, and then you access them. Tests 0, tests 1, test 2, test 3, and test 4. Since, no, not going to talk about pointers yet. So when you're defining it, you give it a data type, you give it a variable name, and then inside square braces, you give the size declarator, which is the number of items in the array. Later on, they start talking about using size of. The size of doesn't return the number of elements in the array. It returns the number of bytes that the array stores, which is really way too technically wonky for the purpose to which we use it, which is to get the length of the array. So the size of an array is the total number of bytes allocated for it. That's different than any other languages, where you call your size of the array the length of it. So if you have int tests 5, it's 5 ints. On our platform, ints are currently 4 bytes each. So if you call size of on it, it's going to return 5 times 4 to give you 20. Long doubles are are 8 bytes apiece. So if you declare 10 long doubles, that's going to be 10 times 8 for a total of 80 bytes. Doesn't mean you can store 80 pieces of information. You can still only store 10. It's just that each element is 8 bytes long.
I think Ken needs to change that. One of his PowerPoints, he talks about how you can go past how much you store in C++, but you can't do it in Java. He says in one of his old PowerPoints.
Well, the word can is kind of nebulous there. The question is, can you go past the end of the array? Yes, you can. C++ does not prevent you from doing it. However, it is a programming error. And Java just flat out throws an exception when you try to do it.
Java stops you from doing it.
Java prevents you from doing it. C++, it's just a horrible idea. It's not against the law, but it's dumb. Okay, so most people, when they create an array, instead of just sticking the number in between the braces, they first create a constant, and then they put the number there. And the reason you do that is so that it's really easy for you to determine the size of the array later, like in a loop or something. And the reason you do that is in this language, there's no super easy, accurate way of getting the size of an array, unlike every other more modern language, like Java, where you can call .length or .size, and it'll give you this length of the array. So store your size in a constant, use that to allocate it, and then whenever you need to know the size, you can use it like that. So something like this.
What would be the reason you need to know the size of it?
Let's get some examples. We want to allow the user to enter 20 game scores or whatever. So get data. They've entered 20 scores by hook or by crook. Now you want to calculate the average score. You're going to have to write a function, unless you know a library call that'll do it for you, to go through and add up all the scores. There is a loop that you can use that does not rely on the size, but more common. Well, how would you put data into this? You're going to need a loop. Your loop is going to look something like this. I is going to be our index value. I could actually write out the whole word if I wanted to. Index is equal to 0. Index is less than 20, so that it'll go 0 up to 19. Index plus plus. And then we ask them for the score. Cout enter score. And then we let them type it in. Like that. Oops, that should be index. If you don't have the size of it, then you couldn't write this kind of loop. Does that make sense?
Okay. So that would have been good for the rainfall program.
Exactly.
Okay.
Guess what you're going to do? You're going to go back and modify it to use arrays. So the problem is, then later on, you quit and then your boss tells your replacement to go and change it so that it's actually got 15 scores rather than 20, and they find where it's declared up at the top, they change that, but they don't change that. And so now it's going past the end of the array, and it's writing into memory it shouldn't be. So if you declare it as a constant, something like that, or num scores, I like num scores, then whenever you want to write your for loops, you just go up to there. Now there is a kind of for loop that tries to know enough about arrays that you can avoid having to use an index counter like that. It's a for each loop. This textbook may have it as a different name, but there's a problem with it. If you use a for each loop, then you can't actually change the array. It's great for calculating averages and sums and stuff like that, but this input would not be able to work. So we'll get to that. Typically, this is how you rip through an array. Really want y'all to have that memorized. You'd use the same thing to get the sum of the scores. You have to declare your variable first. Double sum is equal to 0. Then the same thing for int. I'm just going to use I. I is 0. I is less than num scores, whatever the size of the array is. I plus plus. And then your sum is equal to sum plus, I just use plus equals, scores at that specific index value. Then when you're ready to calculate the average, it's equal to the sum divided by num scores, like that. So please commit this to memory. And this. Now there is a way to calculate the number of scores, but it doesn't work in every context. It doesn't work inside of functions when the array is passed in as a parameter, as an argument. And that's to do this. Int num is equal to the size of the scores divided by the size of one of the elements in the scores array, like that. That's great and all, but if you pass it an array of 0 length, which is actually a valid construct, it would crash because it doesn't have an element and it can't get the size of it. And it also doesn't work if you're inside a function and this array has been passed into you as an argument.
Why do you do the all caps underscore thing again? I forget.
That's just a convention, purely a convention. People in C++ in particular, but also in Java, define their constants as all caps. So accessing array elements. 0, 1, 2, 3, and 4. So if the array is declared as length 5, but you try to access the bracket 5, then you're actually getting the 6th element, and that's an error. Your program might catch it, your program might not. Or when I say might catch it, it might produce a visible error that causes the program to crash, or it might just behave badly. You might get invalid data. So people say the last element subscript is n minus 1, where n is the number of elements in the array. So array elements are just variables. You want to store 79 into an array of numbers, you can do that. You want to print out a specific test, you can do that. If you try to print out all the tests at once, you may be used to doing that in another language like Python, but you can't do that in this language. It's probably about time to pop open Visual Studio.
You can't call all of the elements of the array up at once.
Would you have to just make a for loop and change the subscript every time you
Yeah,
run it?
right. In order to print the entire array, you'll have to iterate through it. And that may be a slightly incorrect statement. I bet that there's a function that you could use that would generate that list for you, but I don't know what it is. So let's write our little grade scoring program. Need a C++ file. Need IOStream and all of our other. Someday we're actually going to use strings, and that's actually going to work, or be of some use. Using namespace std. It'd be worth mentioning again what namespace is good for, because that's one step closer to object-oriented programming, but we'll get there. Int main, return 0, put my pause in front of that. Okay.
I get in the habit of doing that.
So, here's what we're going to do. Declare an array of doubles named scores. Then we are going to let the user enter those scores. Then we're going to calculate the average and the sum. And I could go and just copy and paste from the notes, but you don't have those, so we're going to go ahead and write them. Declaring an array of doubles. How do you declare an array? You give the data type first, then you give it a name, then you specify the number of elements. This did not tell us how many, so let's just say 5. Why not 10 or 100? Because then that's more data we have to type every time we run the program. So int num scores, or num underscores, is equal to 5. I'm going to make it a const. The reason you make it a const is because if you don't make it a const, it implies that that number could change. Somebody might think that they could up the value of num scores later on in the program and magically the array would increase. It would not. Now, although we haven't hit the slide yet that says it, you can initialize your array. If you do that, you're setting every element in it equal to 0. Which is useful because in this language, when you allocate an array, all that's in there is garbage data. It doesn't get initialized to 0 unless you allocate it in a certain place. Instead, it's full of garbage data. The debug compilation fills it with a very specific garbage data so that you can recognize it. But if you compile it for release mode, which is what you do when you make professional software, you have absolutely no idea what is in that data. So you do want to initialize it, you want to wipe it out and put all zeros in there. And that's how to do it. You can also specify more than one value there. If you want the first value to be a 0, the second value to be a 10, the third value to be a 30, or whatever, you can put a series of numbers there, as long as those numbers, the length of those numbers does not exceed the number of scores.
But you don't have to. So even with you putting that, do you have to put the 0 there, or can you just leave?
Well, if you do that, then I don't know what it's going to initialize it to. We could experiment and find out. Let's do that. Let's write a little loop that will print out our scores. Print the scores, so we need a for loop. For int I like I for the index. I is equal to 0, I is less than our max. I plus plus. C out a score at that position, followed by a space, and then C out a carriage return in the ENDL. So let's see what's in that data since we did not initialize it. It's all zeros. Interesting. You taught me something, Adrian. What happens if we leave that off entirely? Yeah, so you see these values, 9.25, whatever. That's a very specific random value that every uninitialized integer, every uninitialized double
Oh, okay.
in C++ gets set to.
Oh, that's the question I was gonna ask you. So, data types do have default values if you don't assign them a value.
No, they do not
don't?
have default data types, but compiling it for debug, Microsoft has decided that they will fill in some default values for you.
Okay, so.
And the reason they do that is to make it fail in a very obvious fashion, because if you ever saw that 9.6 to the power of 63 or whatever, you know that the user did not enter that as their age or height or whatever.
So Java is the only one that has like the default values, like n equals 0 if you don't declare, or.
Even Java will complain. It'll just call them uninitialized variables. The Java compiler catches it if you do not initialize your variables to values. The C++ compiler is there's no guarantee it's going to catch it. But in a lot of places, Java does initialize it to 0, especially when you're defining
The class?
a class.
Okay.
Right.
So that's what it is.
All right, so anyways, those are our default values. But we only got those because it was compiled for debugging mode.
Oh, are you recording?
Yes, I hope so. Please tell me I am. Yes, recording, okay. Okay, so this is an important thing to remember, a loop to print the scores. Remember this too. I'm going to copy that and put it in our notes. So let's let the user enter some data. And there's always more than one way you could do these, but I'm going to just kind of try to drill it into you to use for loops for these. You can use while loops. Anything you can do with a for loop, you can always do with a while loop. So let the user enter scores. Same syntax. Pardon?
Oh, we're not gonna initialize the num scores then? You said we just.
Yeah, let's go ahead and do that. Sorry. As you've said, we could leave off the 0, but I like seeing it there. Makes me feel good. I'm going to leave it there. I could just copy and paste that loop. That would save some time.
Oh wait, if you left the 0 off, then what made it print that out? Oh, it's just what it does if you leave it off. But
If you
yeah.
leave it off, it's still initialized him to 0.
I like seeing the 0 there too.
Yeah, okay.
That's scary.
So what I did is I copied and pasted that for loop, but since this is a data entry, we're going to see out something different. See out, enter score number, let's write out the index. Followed by maybe a nice little colon or something. I feel like that painter Bob Ross, a little happy tree here. Okay, and then let's read in a value and store it into our array. Scores at value I, at index I. Then let's print our array again. So I'm just going to copy and paste this loop that we had here. After you run it, see if you have a suggestion for me about what would make the prompt a little better when it asks the person for their score.
We could initialize we could initialize our index as 1.
We wouldn't want to initialize the index to 1, but we'd want to pretend to the user that it was 1. The reason you wouldn't want to do it at 1 is because you're wasting the first space in your element, and you're probably going to go 1 past the end of your array. If you made I is equal to 1.
Okay.
So, yeah, you can do that, but for this kind of thing, I would just tack 1 on when we're printing it out. So it'll say enter score number 1.
See, now I wasn't thinking that starts at 0, gotcha.
Yeah. Because the user isn't going to understand what scoring
Enter
for
score
0 is
0
unless they've taken
yeah.
our test. I mean, this class. So,
What?
All right. So we've entered the scores. We really don't need to tell the user that they're filled with zeros to begin with. We could comment out that first loop or delete it entirely. You know, I think I'll do that. Since I have the same loop down here, if you only had it in one place, don't delete it. Just move it underneath our data entry. Now we're ready to calculate the average and the sum. Again, we just need a for loop. We could write it out by hand or we could copy and paste it. But you need a tally, an accumulator. You can call it total, you can call it sum. Python programmers, I kept telling you not to call it sum, but in this language it doesn't matter because there is no sum built-in function. All right, so double sum is equal to 0. You do have to initialize it before our loop, and then for int I is equal to 0. I would cut and paste, honestly. I is less than or equal to num scores. But you do have to memorize it, so if typing burns it in, then by all means do that. Sum plus equals scores at value I. Now, since this is only one thing, could we do away with the braces here?
Yes.
Could we do away with the braces here?
Yes.
Could we do away with the braces up there?
No.
Nope, you couldn't do away with these braces because there's two things. And so if the body of code is more than one line, you have to have the curly braces, including closing the body. But we could get rid of them there.
Does it just work off of it just knows that the next thing coming after that is going to be the for statement?
Right,
And it terminates with that semicolon?
right. If I did not have these braces here, here's how it would be treated. Even though it was indented like that, this would be good code in Python, which bases its decisions based on whether things are indented. But in C++ and Java, that's really how it's treated. If you don't have a curly brace, then only the next line is part of the body of the loop.
Okay.
So if you have more than one line, you
I
have
mean,
to put
but,
curly
I mean,
braces.
Could you write those two lines in the same line if you wanted to? This
When I say more than one line, it would still stop.
it would terminate with that
Right, yeah,
semicolon.
yeah. It would terminate after the first semicolon. It would see that. We might think that it's a well-written loop, but it's not. It's still going to treat it like that.
Okay.
So, that being the case, I'm going to go ahead and remove that brace, and remove that brace, and remove that brace, and remove that brace just for fun.
Yeah, but I know I recall you saying just getting a habit of doing that just in case you have to go back
Exactly.
and add something.
The only reason I do that up here is to conserve screen space, get more code on the screen at the same time, and that's a really lousy reason to leave off braces. But you'll see an awful lot of people do it this way without the braces, so it looks cleaner to them. All right, so we have the scores. How do we calculate the average? Double average, and what do I set that equal to?
Average is equal to sum divided by num scores.
Exactly, sum divided by num scores. Now we can print all that stuff out. C out the sum of scores, colon, followed by the sum, NDL. C out the average. We should call it the mean to be all mathematically precise, but everybody knows what an average is.
I haven't heard it called that in a long time.
Remember that there was a difference between the mean, the mode, and the median? Yeah. I don't remember either. I think the mode is the most commonly repeated number in the series. So that if you had the test scores of 90 and then 89, 89, 89, and then a couple of zeros, since you had 3 89s, that's the mode,
The
even
mode,
though it's not the
okay.
average. Yeah,
The median's just the middle.
yeah.
But what if you had I don't remember what you do when you have an even number of things in your list.
I don't recall either how you calculate the median if you have an even number.
You can have more than one mode.
Oh, okay, well. or median for. You can have more than one median, yeah. Median if you have an even amount in your list.
No, it's the average.
Average of the medium two, middle two, okay.
Yeah.
Alrighty, that seems to be working. You can see that this would be this would be very applicable to the rainfall.
Oh, now that you see.
Yeah, especially, I kind of took your instructions literally too, because it said, average them as you put it in, so I wrote a function for like each CN.
Oh,
And I did, and it was just like,
yeah,
there's gotta be an easier way.
I didn't word that very well since I
Well,
led you
I
to
wasn't
think that.
sure, I was just being kind of like, cover your own bases. So.
Yeah,
Well, you wanted us to average it as it kept getting input instead of just averaging it at the end?
I meant for y'all to average it at the end.
Oh, okay.
You could make an argument that you'd want to keep a running average so that they could stop at an early point.
Oh,
But-
yeah, that's true.
That's the same idea as a partially filled array, which I mentioned already. What if you allocate space for 100 test scores, but the users have only taken 80 test scores? You need to keep track of how many pieces in that array actually have good data elements. The first 80 would be valid, but the last 20 would be not. They'd either be zeros or that garbage value that we've seen. So you need another counter that indicates how full your partially filled array is, so that when you calculate averages, you would divide not by the number of scores, but by the current, how many there are in it.
Okay, I see what you're saying, but I'm trying to picture how exactly. Well, like say if you have 10 and they only fill up 7, you would divide your sum. You wouldn't divide your sum by 7, right?
Yeah, you would divide your sum by 7 because they've only entered 7 valid scores.
Yeah, you don't wanna add in 3 zeros.
Could that bring their average down?
Yeah. So then, what would you want to divide it by?
7.
Oh, that's what you said. You don't want to divide it by 7. That's why you had me confused.
Oh, you would. You want to
Okay.
divide not by the size of the array, but by the number of pieces
Oh,
of data
okay.
that were actually.
Gotcha. Sorry.
So let's tack some notes on to that effect. A partially filled array is one that may not have every element filled. So you declare scores as 10 integers. And then you write a little loop that lets them enter data, but you give them the option of bailing out with a -1, something like this. Or int I is equal to 0, I is less than 10. That's bad, I shouldn't have hard-coded, the 10 in there. You say cout, enter score, or -1 to quit, assuming that you don't actually let them. What is that -1 called? That's a sentinel value. So we then read that into some kind of variable, a temporary variable or something. And if they typed in a -1, if x is equal to -1, we want to break. Else, we want to go ahead and fill that value in. Scores at that position is equal to what they typed in, and we need to increment some kind of counter, the number of scores, or data entered, or scores entered. Scores entered plus plus. Now we don't have that variable defined yet. So up here, along with that, we would want to declare that.
Equal 0.
That way, by the time we get down here, we know how many scores have been entered. If we think it makes it prettier to put an else statement in, some people don't like using breaks like that. I'm going to take it out though. We're just going to assume that we know that there's an implied else there.
Is that how the code will read it then? That's how you would actually write it. You
Right.
don't have to write the else.
Right, you don't have to write the else. Logically, it's the same as if you did this. Why is it the same? Because break immediately jumps it out of the loop. So anything after the break is automatically considered to be, an else. That's how it would be treated.
Just a quick question. when it comes to, like, you know how you say some people define all their variables at the top and some define their variables throughout the code. When you have a variable that, I guess, calls other variables inside of it, and you try to define that at the top, how would you do that?
A
Because
good rule of thumb is to declare your data as close to where it's needed as possible. If you have a variable here for reading in data from the screen, there's no reason to declare that up at the very top of the module. You know, you may have 10,000 lines of code, and then you define something called X, and you're trying to remember, okay, every time I read data in, I'm going to store it in X. Nah, just declare something close to it as your temporary variable for holding data. But conceptually, we're probably going to be using this scores array through a lot of this part of the program, so we want to declare it pretty much at the top of whatever function we were in.
I guess so. Pretty much so. I mean, I guess more like like if you have any constants and stuff, that's the stuff that would go at the top.
Yeah,
Those don't
yeah.
change.
Stick the constants up at the top or in a header file.
Because I was like, well, our average, how we calculated that after we did our for loop, the average is something you could define at the top, but you couldn't set it equal to those variables because it'll say those variables haven't been
Right.
initialized.
You haven't calculated an average yet, so why even have that variable floating around making people think that it's there? A lot of folks will do something like that. I haven't seen y'all making this kind of mistake, but for that, you know, weight conversion or whatever, they'll say, okay, I'm going to declare my kilograms, I'm going to declare my pounds, and I know what kilograms are. Kilograms are equal to pounds divided by 2.2. And then they'll ask, okay, see, what is the weight in pounds? And then they'll say, okay, the weight in kilograms is kilogram. And then they wonder why it doesn't work. You tell them, it's not even compiling. Pounds isn't defined. Okay, well, I can fix that. And y'all haven't made this mistake, so I'm kind of belaboring the obvious, but there are people who aren't in this class, who aren't here right now. Okay, this might compile, except it's complaining about an uninitialized value. There we go. Good code, but it's always going to print that kilograms are 0. Why? We don't have this data yet before we try to divide it. Some folks think that because you have this code here, that statement ought to always remain in effect, that it's establishing a ratio, and that kilograms is always going to equal to pounds divided to 2.2. No, that's not true at all. If you defined kilogram as a function, you could do that. If you wanted to, you could come up here and do double kilogram, and then let them pass in pounds, and then you would return pounds divided by 2.2. And so then whenever you wanted kilograms, you just call the function instead.
Does CN work like that? Can you do that with CN?
Yeah, you can. You just have to declare it before you call it. You can't stick this, down at the bottom.
Oh, I mean, like how like in Python when we
Oh,
do our input.
can you define a function inside of another function? Java, I believe, sometimes lets you get away with it. I may be misspeaking there. Java lets you do weird things like define classes within classes within classes. Well, let's find out if this will work. This is just curiosity, but I'm going to take this and paste it into our code temporarily to see if this gives us a syntax error or not. It should give us a syntax error, actually. Yeah, it gives us a syntax error. And the error is that you can't define a function inside of a function like that. We would need to move this up to being above main.
Okay, and then the question about the CN, you know how like you,
In Python, when you do input, and then you can write a string within your input. I was seeing you did that with CN right there, so I was wondering if you could do that with CN. Like how you have CN, the weight in kilograms is...
I've goofed that up. I didn't ever read in the weight in pounds. I had a missing line of code there.
Okay, so you can't...
Like, I should have read that into that, and then this should be a cout statement.
Oh, okay.
Yeah. So if you're wondering what I was doing there, I was totally goofing it. There we go.
I was just hoping you could do it the way you just had it because
I was just gonna let you do
more
it.
simple.
Sorry about that. Sorry about that. Okay, so that works. If you want to define some variable that is based on another one, even this is not good code. We would need to be passing in pounds like that, you know, for that to work. Then what you really want is a function, not a variable. I'll give you another example. We're going to go back to talking about object-oriented programming for a second. In general, this is kind of the syntax for defining classes. I'm going to slip into Java because it's what my brain is on right now, but it's pretty similar. So I'm going to define something called square. No, rectangle. And it's got two sizes, an x height and a y height. I mean a y value. And then it's going to have an area. You could do this, area. This is wrong. And then you let them, you give them some way of setting x and y, and then you give, some kind of calc area function, void calc area, which then calculates the area as being x times y. And so you think, okay, I'm going to use that like this, down somewhere in main. Rect R1, you'd have to use R1 is equal to new R1 in Java. R1.x is equal to 10, R1.y is equal to 20, and then you calculate R1.calc area. This is bad programming, I shouldn't be showing it to you, but I'm showing it to you to try to convince you not to do that. And then see out the area is R1 dot area. This would actually work, but it's got a big flaw. The flaw is that area is dependent upon the value of these two variables. So if one of these changes, area is no longer valid. So if we went down here and then changed R1.x equal to 30, area is no longer valid until they remember to call calc area again. So calc area really ought to be a function that returns the area, and we should get rid of this area variable completely. You don't want members of your class, you don't want variables that represent ratios if it's something that should be calculated. And the way that you decide if it's going to be calculated is, does it have to be correct at all times?
Does this need an input from the user?
Yeah, we should be asking for input from the user to make this good. But if we...
I'm just saying, like, if it's something that needs to be calculated,
Exactly.
you're going to need an input from the user, right?
Right. And so we would want input from the user, and we may want them to have the option of changing it. If they were using a graphics program and dragging squares around on the screen, and a different mouse drag would change the x and the y dimensions of the rectangle, you'd want the area of it, perhaps, to be automatically updated. So you would want to write it as a function. So you'd want to nuke that, you'd want to get rid of that, and you want to make this return a value, and then, you would return, yeah.
Do you want all your input statements to actually be like in your main, all your user input?
It's considered poor form to mix input statements inside of a class that's data. Some people say, I'm going to write a class and I want the class to be able to handle its own input, so I'm going to write a function in there called getData or something like that, and that's a valid way to do it, but you're really supposed to split your code up in such a way that you have data and then you have user interface as a completely different idea.
And that's what the main is the user
Right,
interface.
right. Because you may write a completely different kind of user interface, one that's not based on, typing in, with arrow, a windowed interface or something like that. Okay, and then the last thing we'd want to do here is instead of call r1.area, area no longer exists. We removed it as a variable, but we have our function here, calc area. So, the takeaway for that is if you have a variable that once you're building a class, and again I'm talking about something in the future, If you're building a class and some of the things represent things that should be calculations, don't store those values. People do that because up until this point, we have been storing everything in a value. You have an average, create a variable to hold the average. You have an area, create a variable to hold the area. But once it turns into an object, there are some things that you want to be calculated every time it's accessed. The volume of the sphere, the mass of the sphere, the surface area of the sphere. All of those should be calculations. All of those should be functions that return values, rather than you have to call a special magic word before those things become valid. All right. Gosh.
Sorry, I got you sidetracked.
No, that's all good lecture. We were talking about partially filled arrays, I think, and I think I explained that one good enough. So by the time you get down here, scores underscore entered is set to the value of valid elements in the array. If they never typed in -1, then great, scores entered will equal 10, or num scores, or whatever. I can't help it, I have to fix that. Somebody may come and judge me harshly. All right, so, const int num scores is equal to 10, and then everywhere 10 was appearing, we should do num scores. If we calculated our sum as, the sum of all this divided, if we calculated our average as the sum divided by num scores, it would only be correct if every value was valid. Otherwise, we're throwing in some zeros, and we're bringing our average down in a way that's not fair, probably.
And we understand why you use like the quick inputs you do put up there, because it's quick for examples. Like you're not really. So
Right.
We understand. So
Yeah.
don't be hard on yourself when you do
Yeah.
that.
Yeah.
We understand.
Yeah, there are bad programming practices that I slip into because it's far easier to type and it makes the code look cleaner. This is more cluttered because I add more variables. So, the index can be a variable or it can be a constant. In this case, it's a constant. It's a literal, numeric literal constant. It has to be an integer type. So you could use a variable to step through it, or you could hard code some numbers.
Hey, we already did that.
Here we have an array called numbers. They declared a constant to represent the size. They initialized every value in the array equal to 99. If they were setting it to 0, they wouldn't have to go to such work. They could just do this. That would initialize all of them to 99. Excuse me, to 0. If you did this, hoping that 99 would get copied into the entire array, it would not. It'd only go into the first element. The rest of it would be padded out with zeros.
I guess that makes me curious on why, if you don't put a 0 in there, how come they all don't equal 0? Just because I'm thinking of, if you put a 99 in there, the rest equals 0. But if you put nothing in there,
And if you put nothing in there, then there isn't even a first value, and so the whole thing gets flushed with zeros.
Oh, I thought when we did the double, it was like that big old number, because we didn't have a value,
We didn't have an initializer.
Oh.
Yeah. They could have written it in such a way that when you declare the array, it would automatically initialize everything to 0, but that's extra computer cycles, which you may not want to be using. So, when they get initialized, if you write a so-called global array, if you declare it outside of main, all the elements are initialized to 0 by default. But if it's a local variable, a local array, then they are uninitialized. I wish that there wasn't any difference, honestly. If you have to get used to doing it in one place, you ought to have to get used to, oh well, anyways. No bounds checking in C++, meaning that you have to make sure yourself that you're not reading past the end of the array. So when you use a variable as an array subscript, C++ does not check to make sure it's a valid subscript. You can use subscripts that are beyond the bounds of the array. So in our program here, I'm going to copy this printing loop, the loop to print the scores. But I'm going to print out more than 5 scores. I'm going to print out 25 scores. We don't even have 25 scores. The array is only 5 long. So 100, 90, 80, 70, 60. Oh, I put that after the pause. That would be why. Move the pause down here. Okay. 100, 90, 80, 70, 60. There we go. We started plowing into some other data. And notice this time it's not even initialized to that special debug value.
Only the first two.
And the reason is we're just read past the end of the array, and whatever is stored in those bytes after that, it's pulling them out and treating them as though they are doubles. And those could be, usernames or, MP3 files or whatever happens to be stored right after that array.
Did you cast those values to be ints?
I wasn't casting them, we could, but if somebody earns a 98.4 and you want to keep that 0.4.
I meant the ones that
Yeah,
they're just
students
grabbing.
are picky, man. They're gonna be crying about their grades a bunch, I bet.
See what happens there.
I was just wondering if it would convert those doubles that are out in the middle memory to. Yay.
Seems to be some consistency to what it's putting in there, but it's still invalid data. And you could just as easily crash the program as merely get data which is not valid. It's worse if it doesn't crash, though, because once you print that the user scored, -2 billion is their average, hopefully they'll catch that. But if you're adjusting, the amount of propellant to feed to the nozzle in a missile, you don't want it deciding all of a sudden that, it's going to feed in -2 million or whatever. So it's best if it just crashes. And what I mean by that is that if during testing you can see that there's a problem, it's far better than if the problem is hidden.
Gotcha.
Which is why Java made the decision, to throw an exception to cause a crash anytime you go past the end of an array. Whereas C++, yeah, why not? You can do it if you want. It's not smart, but you can. You can use subscripts that are beyond the bounds of the array, but you better not. I'll put that into our notes. But you better not. The data is, at the least, invalid, and may also crash the program when it is accessed. Windows may catch the fact that you're trying to access data that's outside the range the program should usually be able to get a hold of. The program has encountered an exception and must be shut down. I like shut down. We can belabor the point. The following code defines a 3-element array, but then writes 5 values to it. It'll crash. And we've got 3 elements in the array, but then we kept writing. Conceptually, there are bytes before the array. So if we accessed element number -1, we'd get whatever data was there. -2, we'd get data that was there.
That's cool. So, is there a way we can control what those elements are, too, also?
You
have
could
an array
declare,
with negative elements?
you could declare,
Could you
well,
start it
let's
as
play
negative
with
element?
that concept a little bit. We're gonna go up here and before this scores array, we're going to declare another array of doubles called before junk. And it's just gonna equal a couple of very specific values. OX, FF, OX, FF, OX, FF. We're gonna do the same thing after it. We're just playing. So now our array, now our data consists of an array of valid data, but there's also some space before it with some values, and there's some space after it with some values. So when we go and we keep reading past the end of the array, I wonder if we're going to hit those FFFs, which will print out as 255. There they are.
Oh, cool.
Those are the three values after our. So one
What
old
is
stuff.
that first one though? The first one doesn't initialize, it goes straight to the,
Right, we didn't try to access it. We didn't start our counter. We started our counter at 0.
oh.
We'd have to start it at -3 to get those guys.
No, I mean, there was one, that one was just there.
Oh, he was saying like after you put in your value, there was that 2 billion number.
Yeah,
Right.
see, look, after the 50, there's a 2 billion before the 255s.
Interesting.
And there's one before the 90 also.
Yeah.
Is that
It
your
may
zero?
be, maybe it's a consequence of it defining, of it being compiled in debug mode. Maybe that's why we're seeing those values there. I was about to mention that people used to do this kind of thing before and after arrays because you could then go and check for possible data corruption. If you knew that all of the data in your before junk and your after junk were supposed to be 0 FFs, then you could go and check to make sure that they are still 0 FFs after, after your program has run for a while. And if there's anything else in them, then you know there's something wrote past the end of an array. That's kind of old school, but it could be that in order to check for data that's written out of bounds of the array, that the debug compiler is in effect sticking, little arrays here of length 1 with that hard-coded value in it. Let's actually write some data into the, if it goes out to scores 5, let's write a 5 value and set it equal to, 36. And let's write out a 6 value and set it equal to 37. And now when we print those pieces of data out, $60, $70, $80, $90, $100.
And it puts them on there, it doesn't average them or sum them up though.
Right.
Could you put them in there?
Well, we could make them, we'd have to modify the sum loop in order to include those. So my guess is that whatever that -214 billion there that was there before, we have overwritten it with a 36. I'm guessing that if we hit enter and close this, it'll warn us. Runtime check. The stack around the variable scores was corrupted. So I think that it's inserting little hidden variables in there to catch errors. And that after the program is run, it goes in and it checks. Oh, by the way, if this value doesn't equal -214 trillion, then that means that we corrupted the data. And again, that only happens if it's compiled for debug mode. How do you change that? We should be able to change the way that it is built in the configuration manager. Active solution configuration. So I went to build and I chose configuration manager and I can say that I want to compile it for release. Now when I rebuild the solution and I run it, start without debugging, it's probably not going, well, we will see some dramatically different results. No, it still filled them with 2 millions. but it didn't tell us that it was corrupted. So if we looked at the executable size and compared the release mode to the debug mode, we'd see that the release mode is much smaller. The debug mode has a whole bunch of extra information in it that lets the debugger step through it, you know. Otherwise, how would, you know what the debugger is. We haven't run the debugger too much. I'm going to switch back into debugger mode. I'm going to go to Configuration Manager, say that I want to compile for debug, build it for debug, rebuild solution. And the way the debugger works is you set breakpoints, and it stops at that breakpoint, and you can keep tracking what's going on. Go to the next line, go to the next line, go to the next line, and if you're curious about what these variables are, you can hover your mouse over it. Scores is an array of 5 long. Not that you can see those numbers, but they're there.
So zeros.
Yeah. Keep going. There's a function key which represents step over, but it does something bad to the recorder. It stops the recorder on my machine. So, yeah. If we look at the debugger, it doesn't know that there's a 36 and a 37 that have been written out there because it thinks that the scores array is 5 long, and that's what it's displaying. And it really is 5 long, so we've written outside the bounds of the array. Now we're entering a loop with the debugger. There we go. We're going to ask for the score. So now it's hanging, waiting for us to type something in. So I'm going to type in 99. I come back in here, and now the scores array has a 99 as the first value. And we hover our mouse over the I. Well, it's hard to hover our mouse over the I. I guess maybe I can do it up here. I is equal to 0, but when I click next, it's going to come back up here. Step over. Comes back up here. It adds 1 to I. And so now I is equal to 1. And so the next value that we type in is going to come into the second place in the scores variable. So that's the debugger mode. And you can't do that kind of stuff if it hasn't been compiled for debug release. Now a classic, I won't say hacker thing, but diagnosing somebody's software, reverse engineering it, you know, that's really common when you're trying to figure out, you know, what some bad software has done to your machine. You can get that program, and if they wrote it in Microsoft C and they left the debug information, it's far easier to figure out what the program's doing. So, you know, bad actors usually compile their code without the debug information. But in general, you're supposed to do that anyways, just because it makes the executable smaller and it runs more efficiently.
It's also like an intellectual property
Yeah.
saving type deal, right? I mean, if you don't include the debug property.
Yeah, they don't need to see all that information in it. Yeah. Yeah. They're buying a product from you. Now, if you're doing open source software, you ship them the source code, you know. So if they need to change stuff in it, they can do their own debugging.
A lot of software now still, they just didn't include the debug. Like especially a lot of video games now.
Yeah.
They're including the debug stuff. And actually, I found out online, I was really excited that I found out online they Grand Theft Auto 5, they just found a bunch of information in the debugging stuff that it like alludes to some of the DLC that's going to be coming out.
Oh, that's funny.
Yeah, no, it was super cool. I was like, they're like, oh, we found all this stuff for alien saucers and all this stuff for aliens and new
Yeah.
combat units. But where are all these people in the game right now?
They'll be coming.
I
Okay.
was like,
Yeah, that's
oh,
interesting.
man.
Well, the way programs are shipped now, you know, they're quite often shipped out, you know, even before they're really totally finalized. And then you know that DLC is coming down the pike anyways, but, you know, so they're letting their user base, you know, debug their software. It's not surprising, I guess, that they include a lot of debug information in it. All right, so we're going to talk about the idea of parallel arrays now. And to do that, I want to rewrite our code significantly, and I don't want to have to keep entering those 5 pieces of data anymore, and we added a whole bunch of junk to this one. So either comment this stuff out completely, you know, put a slash star there, and then go to the bottom and do star slash, or if you want, just start a new project. Either way works.
auto completes the comments.
It did, yeah, so I had to delete those to move them down to the bottom. So I'm starting a new main, and I'm putting the system pause in it. So what a parallel array is when you have more than one array where the data is thematically linked. For example, you have a name and you have an age. So we would allocate two arrays. We would allocate a names array and an age array. And an element 0 in the names array would be Adrian. And element 0 in the age array, I think I said that backwards, would be 40 or however old you are. And then we'd go to you, and you would be index element 1 in both of those arrays. And then you would be index element number 2 in both of those arrays. So, parallel arrays are when you have two arrays of the same length. Two or more. When you have multiple arrays of the same length that are conceptually tied together by their index values. So back to the idea of our elements. We could have element names where I'm going to cheat. Element number 1 is hydrogen, And the atomic mass for that element is 1.0004 or whatever. And then element name 2 is helium. And the mass of a helium molecule, I believe, is 4. I could be wrong. Like that, So, and you could have more traits. The number of neutrons in it, A hydrogen atom has no neutrons whatsoever. A helium atom has two neutrons.
I wish I retained chemistry.
You know what, now I'm curious enough now that I'm going to look up the elemental chart.
It's the one that was in our book.
Come on. Not really. Just give me the chart. There's one. Yeah, that's why the atomic mass, the atomic number, not that this is a chemistry class, represents the number of protons in the atom. But the mass is the number of protons plus the number of neutrons. So helium has 1 proton but no neutrons, or hydrogen does. Helium, the next one, number 2, has 2 protons, but it's also got some neutrons, so its mass is 4. Lithium has got 3 protons, but enough neutrons to pad out its weight to 7 or whatever. But anyways, so now we are tracking 3 different pieces of information for each one. We have 3 different arrays. That's one example. Another might be, month name. You could have a month name where the first one, I'm going to slip back to using 0, is January. And the rainfall for that month is 12 inches. And then the month name of the second month of the year is February. Did I misspell that? And then the rainfall for that month, is 2 inches. And so on. So you have multiple arrays of the same length tied together by their index value. That's what parallel arrays are. One common use of them is just to make data entry look better. Like if you write a program where you're asking for, the days, something for the days of the week. Temperature for 7 days of the week. So let's declare an array of days it's going to be strings. If you do not put a size when you declare it, it auto-sizes it to the number of values in the initializer list. So Monday, comma, Tuesday, comma, Wednesday, and so on. I'm going to stop there. Why? So that we only have to enter 3 pieces of data. It would be really nice to know how long that array is. And I'm not sure I can do this. Let's find out. Constant int num underscore days is equal to the size of the days array divided by the size of a string or the first element of the days array. Either way it would work. Why am I going to do that? Because I need another array now that represents the temperature for that day. I could have just hard-coded num days equal to 7 or to 3 or something like that. But instead I'm making it dependent upon the number of values in the initializer. By the time this code executes, num days will equal 3. But if I go in and add the other 7, fill it out to 7, then num days will equal 7. That's the only reason I did it like that.
Okay, so how come we weren't using size of earlier?
Because it's not valid in every place.
Okay.
What do I mean by that? If we pass days into a function, then we're no longer guaranteed that we'll be able to use size of in order to get the size of the array accurately.
Oh yeah,
But
because
when-
then you say it changes like the byte size or something like that.
Yeah, it's totally not reliable to use size of in any other context except when it's your local to the same place the array was declared. But since I'm declaring 2 pieces of data here, one right after the other, it's totally fine to do it that way. But I'm getting kind of bugged by it. I'm going to change it.
Sorry.
Const int num underscore days is equal to 3. And we're going to initialize days equal to 3. And then our rainfall, our temperatures,
Yeah, let's do it. Well, let's just-
I'm just going to call it temps. I'm going to initialize them all to 0. Now we're going to write a little data entry loop. It says what was the temperature for Monday, what was the temperature for Tuesday, and what was the temperature for Wednesday. See out. Wait, nope, we need a for loop. For int I is equal to 0, I is less than the number of days, I plus plus. We're going to write out a message. What was the temperature for, followed by whatever element of the array matches what day it is. Then we need to let them read that in. CIN into the temperatures array for that specific element. Now we're going to print it as a table. But we have more than one piece of data to print out. So we don't just want to print out a series of numbers. We want to print out the name followed by the number. And rather than use set W and things like that to make it fancy, I'm just going to use tab. So for, I could copy and paste the loop, that would be faster. I is equal to 0, I is less than num days, I plus plus. Let's write out what day it is, followed by a tab, \T, followed by the temperature at that position, followed by ENDL. and it printed a cute little table. Monday, Tuesday, Wednesday, 30/20/10. See, you can tell where I'm taking this. You get to modify your rainfall program to store your data in an array and to ask it specifically month by month using an array list of names, a list of months. Calculating the average temperature would be just as easy as it was for our other.
Well, don't tell us how to do it all. Make us do some of it.
Yep. What I do want to show y'all something about calculating the average. And it would be useful in this context to talk about it. I'm not coming up with another way to broach the topic. You can pass in an array as an argument to a function. Yeah, instead of, rather than calculate the sum and the average, since I want to leave that for y'all, let's write a function which will print that table. So print, or I'm going to declare it as void because it doesn't need to return a value. Print temp table. We need to pass in the name of the array. We could give it the same name, or we could give it another name. It doesn't matter as long as it's of the same type. It's an array of doubles. I'm just going to call it TA for temperature array. And then the size of the array.
It made my TA gray.
Mine
For
too.
some other reason.
Apparently it's making all the parameters gray.
Huh.
And then we need a for loop. So for, again, I is equal to 0. I is less than size. We're not going to use that constant because in this context we don't know what the constant is. But we did pass in the length of the array. But this isn't going to work because it's not printing, we're not passing in the days as well. This was a bad example. I'm kind of not liking that one. I'm going to nuke it. Sorry. Now I am going to leave it. But all this does is print out the raw values, and it doesn't print them out by month. So C out the temperature array at that element, followed by a space, and then C out the end of line, like that. Now whenever we want to print the values, you just call it like this, print, I don't like this function name, it's too long, print underscore temp underscore table. We pass in the array, temps, and we pass in the size, num underscore days.
Why is your TA gray? Oh, because.
I'm not sure why. Oh, look what I did wrong. What did I do wrong? I'm trying to treat this as though it were an array, but it's not, it's just a double. It's a single value. There you go. That'll fix that, and it'll fix it down here as well. So you could write a function that would calculate the sum, and it's a very common thing to do. You know, void sum, and you pass in an array, the size of the array, uses a for loop to rip through the, the array, summing them all back, and then returning that value. And you could write another one, average, that would do the same thing. So in other languages, it is completely superfluous to be passing in both a size variable and an array, because you can ask the array how long you are. But in this language, you cannot. On the other hand, it's useful to be able to specify, what if this is just a partially filled array? we wanted to get the sum of the first three values of the array, even though the array had been allocated to 1 million items long. You could pass in a 3. It's okay, you know, to access less data than the array is sized out for. It's just like using part of the space in your house and leaving the rest of it unused.
We're in 2017 and they still haven't found a way to make C++ do that with arrays.
Yeah, you use a different data type if you
okay.
want that kind of stuff.
Okay.
And one of the PowerPoints talks about an array, a data type called a vector, which is the equivalent of the list in Python.
So what would be the, I guess, what would make you want to use a list over a vector?
You mean an array over a
array,
vector?
yes, sorry.
Arrays are by far the fastest to rip through, and they are not dependent upon a class. You know, if you're going to access a class, then there's some overhead involved in that. You know, if you want to check the size of it, you know, you have to call a method. If you want to access each element, it has to invoke a method. It has to do a couple of lookups. So that would really be the only reason I could give you, is for absolute speed, nothing beats a raw C or C++ array.
Gotcha. But I mean, it's just like with the string, but since we wanted to do all the fancy stuff that we do with strings, that's why we have a string class, I guess. Or
Yeah, yeah. I mean, dealing with lists of numbers is such a common problem that if they did not give you libraries for handling that, if they did not give you classes for doing it, you would wind up writing your own, you know, and it would take you a bunch of time, you know, to write one that was really good. So it does ship with the vector class along with some other classes that implement lists. And what is a list? It's a resizing array. When we declare this array as 3 long, we can't then go and change, oh, by the way, I really wish it was 4. I'm going to change it to 4 on the spot and then add Thursday to it. Once an array is allocated, it's set to that size. It's fixed. You could reallocate it, but then you lose all the data that's in it, just like our test question. You know, if I turn around and then later on reallocate the day's array to 7, then I'm going to lose this Monday, Tuesday, Wednesday. Or if I decided that I needed more temperatures than 3, and so I reallocate it to be 7 long, then I lose all the data that's already stored in it. So in general,
All your 100-degree days, that wouldn't be a bad loss.
yeah. Arrays, once declared and allocated, are fixed in length. They do not shrink and grow as data is added to them, like lists do. The same is true in Java. A Java array, once you declare it, it's fixed in length. And so you use array lists in Java in order to get a data class, you know. Because it's kind of a drag if you don't know how many test values are going to be, so you allocate 100 of them just to make sure you have enough room for it. It's kind of wasteful of memory.
Right.
So you use a data structure that supports dynamic data sizing. In Java, it's called an array list. There is a vector type in Java too. And if you want to use the same names you use in C++, in C++ you use the vector class. All right, so what is our homework going to be based on this stuff? I'm just going to go grab the description for the rainfall, and we're going to rewrite it.
You know, when I started doing it, I actually did put it in a list, and then I was like, what am I doing? I don't know how to work a list in C++ yet.
Yeah.
I think that's
Sounds
honestly,
pretty easy.
Well, that's the good thing about learning, you know, once you learn one programming language, and then you learn another programming language, and then you pretty much are set, because, you know, you could go into C++ and you could find out how to create a list, you know, and then you could do all the same stuff that you were used to.
I think that's honestly the first time I've slipped into other sentences.
Yeah.
I'm usually pretty good at
Yeah.
keeping them out of each other, but I don't know.
So here's what you said, you know, my thing was nebulously worded. As they entered the data, sum the scores.
Yeah, that's what I
It should have been once the data.
I wasn't sure if that's what you really wanted or not, so I just made it do it. I was like,
Yeah.
I mean, it's not gonna show up in the background, you wouldn't really know unless
Unless you
looked at
print
the
it.
code.
Yeah.
But, I'm just gonna go ahead and just because it was like one more function to put in each time, so I was like, whatever.
So write a program that will ask for 12 rainfall values in inches. When they're done entering the data, print the sum rainfall for the year and the average rainfall per month. And the average. So, but the difference is that the input should look something like this. Or 1, be sure to use arrays to store the data. The input should display the months. What was the rainfall for January?
Oh, okay.
That's how I set my name too. I was like 12.
Did you hard code it in there, or did
Yeah.
you? Okay, that's okay. I was about to say, or did you use the how he stored it?
No, I hard coded it.
Yeah. You ought to be able to use a loop. You should be able to use a loop for data entry. So when they are done entering the data, print the total sum rainfall for the year and the average rainfall per month. Also, print the data out, by month. So let's change that a little bit. When they are done entering data, you want to print the data out by month. Print the sum rainfall for the year. Print the average rainfall per month. And then something we haven't talked about yet, which is print the lowest rainfall and the highest rainfall.
There better be some built-in function
Nope.
for you to...
No, you're going to roll your own to do that. So we're going to save that for Monday, I believe.
Print the lowest rate.
So I'm not obviously not
It's
going to
due
make
on
this
Monday.
do.
It's Google time.
Yeah, no, I'll figure it out.
Yeah, yeah. Yeah, to get it done over the weekend, you could Google it up.
But I want to figure it out on my own. But then
Yeah,
I don't know
I'll
if
find
there's
out.
a... That's what I'm saying.
Okay, I'll give you a hint.
No.
You don't want a hint.
Yeah, don't hint. Wait till we leave and you can.
All right. I want you to struggle with it. But then on Monday, I'm going to show you all how to do it because
That's
it's not
fair.
going to be due until Tuesday night anyways.
Want to be done Monday. So can
You
see
will
as an example.
definitely use a loop to calculate the sum,
Oh, I
average,
think I got it.
lowest and highest.
I think I got it. Well,
And this one doesn't have to write to a file or anything like that. We already made writing to a file a modification of the rainfall. I'm hoping that this is different enough that you'll start this one from scratch.
I'll probably start in both.
Yeah, that's what I was already. That was all that stuff I have hard coded in mine already.
Yeah.
I'm like, yeah, I'm just gonna grab it.
Note, I would start this from scratch rather than reuse another rainfall program.
Because, okay, it's going to be similar to like...
No, don't tell me either, man. I haven't thought about
Well,
it.
you
I'm
haven't
just
done,
like,
have you done a password
Huh?
validator? Have you done a password validator?
uh-uh.
Okay, well, would it be like iterating through a password validator for highest and lowest?
You are going to iterate. I don't want to talk. I don't want to give any more hints than that.
Okay, yeah, that's I know what to do now. It's the power of iteration, my friend. Yeah, I think you'll get it.
Yeah,
pretty fast.
it won't take me long. I'll figure it. I'll look it up if I have to. I'm not worried about it. I like to have that opportunity, though. You know,
Right.
Yeah.
Because I did a, whatchamacallit, I don't think it was coding bad. I don't know what I was on, but I did an assignment that was similar to, it was just like, here's a bunch of numbers, write a loop that stores the highest and lowest, but if the user enters another higher number, it overwrites the one that's already in there.
So, since there are bounds checking, be careful not to use invalid subscripts. Doing so can corrupt other memory locations, it could crash the program, it could lock up the computer. That doesn't really happen hardly anymore unless you were writing low-level driver software. But back in the old days, computers did not make sure that your program, it was really easy for one program to crash another. Nowadays, the modern operating systems go to a lot of effort to make sure that Word can't kill Chrome and vice versa. An off by one error happens when you use array subscripts that are off by one. Sounds obvious. But for example, you say, I want 100 numbers, but then you start counting at 1. You're supposed to start counting at 0. The consequence of that is that once you get up to element number 100, you're writing past the end of the array. Now there are times when you allocate an array strictly larger than what you need. And what do I mean by that? I'm just going to draw a picture up here so the poor people who are watching the video aren't going to get to see it. Say you want to write a program that's going to roll random numbers with 2 dice, and then it's going to figure out, which ones are rolled the most often. How many times a 2 was rolled, how many times a 3 was rolled, a 4, a 5, a 6, a 7, an 8. A 10, an 11, and a 12, like that. Okay, when you're writing a program like that, it is so useful to be able to say, D at 2 is equal to, I rolled that. I rolled a 2, so I'm going to increment it like that. And then later on I rolled a 7. It is so useful to be able to use this number as what you rolled and the index value that it's worth allocating the array larger than what you need just so that you can ignore those 2 values. Because it's impossible to roll a 0 with 2 dice. It's impossible to roll a 1 with 2 dice. You could allocate this exactly to the right size. How many possible values are there?
14. I was going to say 10. Is there
One?
10?
No.
Oh, 10, yeah, no. Possible, yeah. Sorry.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah, so there's 10 possible values, which is weird. I mean, you think you're rolling 2 dice, there ought to be 12 possible values, but there's 10
0.
possible values. And so by allocating it so that you can access the elements directly by the number of the roll, it'd be a lot easier conceptually to think of it. And yeah, we're wasting a little bit of space up at the top. But you could certainly modify it, so that you rolled a 2, so I'm going to add 1 to element 0. You rolled a 3, so I'm going to add 1 to element 1. You rolled a 4, so I'm going to, you could do that manipulation just like we did with the data entry, enter score number 1, score number 2, score number 3. But sometimes, conceptually, it's so much clearer if you just waste some space.
I think you should make this a bonus assignment.
That'd be cool. Bonus assignment. Everybody's already making an A already. That's not true. So,
I just want, to be honest, I don't even care if it's for credit. I just want to do it,
all right. That's a good idea, though. Let's do that as a project. Write a program that generates 2 random numbers representing dice, adds them together,
Crack open the random generator that we did and see how that syntax looks. I hope I commented it.
I will come up with a written description of this.
Oh, okay.
It'd be fun. Having it re-roll once on the D&D character sheet.
Yeah, that would be fun. Another interesting thing to do with the idea of D&D character generators is letting them roll 4 dice and then just pick the 3 highest. And things like that. To do that kind of stuff, it would be good to put your dice rolls into an array so that you could, sort them and then lose the lowest one. 5 numbers and keep the highest 3 or that kind of thing. Or just like you said, just go through and then replace all the ones with new random numbers. I will write this one up as a program description. So this one generates 2 random numbers, adding them together. Do this repeatedly, keeping a tally of how many times a 2 was rolled, how many times a 3 was rolled,
Total summation on all the rolls.
and so on. Yeah, the total. And so on and so on. How many times times a 12 was rolled. Instead of saying let's do this repeatedly, let's say do this 100 times. And you should get a bell curve. You know, it's far less likely that you're going to roll a 2 than you're going to roll a 7. Why is that? Because
There's more ways.
you have
to
more
add
combinations,
seven than
right.
there are to
if you were going to make a little table,
You have you've got 2 1s, 2 6s, and 2 3s and 2 4s, and for the 2 you only have 2 1s.
exactly. Yeah, how can you roll a 2? A 1 plus a 1.
And then
But
seven,
for
you
to
got
do a 3, you can roll a 1 plus a 2,
or a 2 plus a 1.
or 2 plus a 1. You get a 4, you know, 1 plus 3, 3 plus 1, 2 plus 2. Something like that. Anyways, you get the idea. So 7 is by far the most common. This is called a frequency table. Then print out the frequency table showing the percentage of how many times 2 was rolled, 3 was rolled, etc. So this is more like a project. I didn't have any projects.
Yeah, I guess I haven't had a project
go.
yet, so that's why I'm kind of like.
Yeah, I'm going to do that, and I'm going to leave it alone without giving y'all any hints about how to do that. So the project's optional, but it'll be to your advantage to do it.
Did you used to have your finals be projects, or have they always been tests?
In advanced Java, I make it that if they do a project, they can skip the final. All right, so I'm going to need to write that one up. Post it.
When I did the intro to programming, Professor Johnson did a project for
You did?
yeah, it was nice.
Did you? Was that in Python?
I think it was like Java.
When did
I don't
Python?
even remember now.
When did Python become the intro language here?
Maybe 3 years ago.
It's been a while since I took that.
Oh, yeah, gotcha.
Alrighty. Initializing an array. You can initialize your arrays with an initializer list, just like we've been doing. Like that. You want to preload your array with data? You can certainly do so. The initializer list cannot exceed the array size. However, you don't have to define the size of the array at all. If you're just willing to go, okay, I want there to be 5 elements. That would fill it with 5.
You couldn't fill an array with, like, say you did, like, the random, you couldn't just put a bunch of random, well, I mean, you could store it in a variable, and then I guess put the variable in those?
Well, what you're asking is
Yeah,
if
like,
you could
can
do
you do
something
that?
like that. I honestly don't know. I don't see why that wouldn't work. You know, fill that up with random values.
Huh.
I would expect that to work. So if the number of initializers is less than this number, then it gets padded out with zeros out to the end. We're going to stop pretty soon. Implicit array sizing. Implicit array sizing is when you leave off that number. But if you leave that number off, then you no longer have the cute little constant that'll tell you, you know, that there are 4 elements in it or not. That's what you can use that size of for. And here we go. What if I don't want to use a num underscore scores to print my values out? That's called a range-based for loop. And this was added to C++ not too long ago. C# and Java have had it for quite a while. It looks like this. So instead of doing this, for int I is equal to 0, I is less than, number scores, I plus plus, C out, or sum is equal to, sum plus equal to, scores at I. That's how we've been doing it. Instead you do this, for every value in the scores array, the sum is plus equal to the value, like that. This is called, what did they call it? Range-based. You can tell the syntax is a lot simpler,
And that works
a
the
lot
same?
shorter. It works the same. Honestly, I don't know how they made it work if you don't know the length of the array. What kind of ghastly trickery they built into the compiler to get it to work.
Or where's the
But that is the
increment?
same syntax you use in Python, except you replace the word, you make it look like this, for double, or for V in scores, you know? That's how you do it in Python. In C#, which is where I think it came from, for each V in scores. That. In Java, Java is the same as C++, or vice versa, because C++, Java had it first, and so on. So what this means, this code right here would be the same as if you wrote it like this. I'm just going to copy this code here. These two things do exactly the same thing. They are absolutely equivalent.
Where's the incrementer for the first one?
Yeah, there's no incrementer for it.
So-
It's implicit. It's implied.
Oh,
Just like in Python, when you're stepping through a list, you don't see the implementer, but there is one. So the difference is, yeah, in this case, you don't have an incrementer variable, which is why you don't use this kind of loop if you want to change the value of the array. If we wanted to be changing the scores as we went along, if we wanted to be reading values into the scores array, you could not use a range-based for loop. You could not use a for each loop. Why? Because it's getting a temporary, it's using a temporary variable to copy each element of the array in turn before you do anything with it. V equals the first element of the array, and then it equals the second, and then it equals the third, and then it equals the fourth. And if you change it, big deal. You know, the next thing that happens is it's going to get reloaded with the next element of the array anyways. We're not touching the scores array itself. We're only getting to see a copy of it item by item. Just like this. We copy a specific element into V, and then we can add V to the sum and print it out or whatever. But if you change V, big deal. It didn't change the scores variable. So these two are exactly the same. Are these two exactly the same? Not really, because we can modify this to modify the data as we were running through. If you did scores sub I is equal to 0, that actually is erasing your array as you step through it. Probably not what you want, but you could. But there's no way to do that with this syntax. Another good thing about this syntax is there's no way to go past the end of the array. We're not having to put less than num scores. We're just saying, hey, step through the array. So this is really nice for doing sums. You do have to initialize your sum variable. Sum is equal to 0 beforehand. It's also a really nice way to print them out. You know, you don't need an I counter to print them out. On the other hand, if you're printing out a table based on a parallel array, yes, you do need an I, because you need to be able to link two separate arrays together. January's rainfall. The month name is one piece of data, the rainfall is another. You need that I in order to be able to print the January and its rainfall.
Do you need, are you gonna need the I for like average then too?
No, because if we did this, I'm going to move this down here. Sum is equal to 0. You can do average is equal to sum divided by num scores. You still have to have some way of calculating the number of the scores for that to work, but you don't need an I to do that.
Okay.
This is kind of tacky, but you could do this. I love showing y'all tacky stuff just to confuse you. Sum is equal to 0. Count is equal to 0. For double V in scores, add that score to the sum, add 1 to the count, and then average is equal to sum divided by count. Like that. Then we're not relying upon, you know, a hard-coded constant we're using size of. But that's kind of tacky. That's why people in C++ traditionally use a constant to allocate their array so that they can refer to it when they need to. And this thing exists in both Java and in this language and in Python, so it's real good to get used to the idea of range-based for loops, as they are such a better syntax for stepping through them, not for changing them, not for filling them with data, but for accessing the data in order to print out the data out or calculate the sum or to, you know, find the mode and the mean, whatever you're trying to do. All right, let's call it a day. Dropbox for our daily work.
Is Mr. Johnson back from his vacation?
I don't know.
Have you not seen him lately?
No. Yes, I saw him today. So Steve should be down there. So this will be Dropbox I. I'm just going to call it arrays because I don't know what else we did. Alright, so you can upload your CPP file into the arrays Dropbox and the Dropbox I.